Well, hello and welcome to today's webcast, Statistical Quality Control, with guest speakers Brenda and Jose Ramirez. Brenda Ramirez is an industrial statistician with many years of experience working in semiconductor, chemical, and biotech industries. In this role, Brenda partners with engineers and scientists to bring new products to market, to sustain manufacturing operations, and to guide process improvements through the union of science and statistics. She's spent her career using and advancing statistical quality control techniques such as SPC and process stability metrics. Brenda received an MS in Applied Statistics from Worcester Polytechnic Institute and an MS in Industrial and Management Engineering from Rensselaer Polytechnic Institute. She's an avid user of SAS and JMP statistical software from SAS. Her stability ratio, which is used to classify a parameter as stable or unstable, was included in JMP version 13, so she's actually contributed to development of JMP. Jose Ramirez is a statistical engineer with years of experience in semiconductor, electronics, and biotech industries. He's been a JMP user for more than 25 years. He works closely with engineers and scientists to help them make sense of data, and through collaborative education, he helps promote statistical thinking and JMP usage. He received a degree in mathematics from Universidad Simón Bolívar in Caracas, Venezuela, and both an MS in Applied Statistics and a PhD in Statistics from the University of Wisconsin-Madison. He's one of the founding members of the Center for Quality and Productivity Improvement at University of Wisconsin-Madison. And at the 1998 International SAS Users Conference, Jose Ramirez won the Best Contributed Statistics paper. In 2002, he received the SAS User Feedback Award. Brenda and Jose have also written another book together through SAS Press. Their previous book, called Analyzing and Interpreting Continuous Data Using JMP, a Step-by-Step Guide, won the 2010 Award of Excellence in the Society for Technical Communications International Technical Publications Competition. So we're really excited to have Brenda and Jose here to talk about their new book about statistical quality control based on, so they're using JMP to do the exercises and things for statistical quality control from the Doug Montgomery Statistical Quality Control book. They'll talk a little bit more about this and they'll show us some examples. And then we'll pause a few times through the webcast to take some questions. So if you've got questions, send them to me in the chat or the Q&A. And as we take those pauses, I'll make sure to convey all those questions to Brenda and to Jose. So now we invite you to sit back and relax, and we will go ahead and get started.
Good morning, everyone, or good afternoon if you're overseas. Brenda and I are really glad that you can join us today. And we are very excited to share with you this recent book we have published, which is a companion book to Professor Montgomery's Introduction to Statistical Quality Control. If you're in industry applying SQC techniques or you're in academia teaching SQC, you are probably familiar with Professor Montgomery's book, which has become a standard both in industry and in academia for quality control techniques. So today, Brenda and I are going to talk a little bit about SQC or book, and we're also going to run some JMP demos to show you how easy it is to use some of these techniques, and also show you some of the new things that they have included starting in JMP 13 and JMP 14, new platforms and new things like Brenda mentioned, the stability ratio is one of them. So.
Okay, well, thank you so much for the introduction, and thanks for attending, everybody. So I'm Brenda. Pleasure to meet you all. And so when we were asked to write a companion book to Professor Montgomery's book, we were really excited about it because we have benefited from the learnings of Professor Montgomery for many years throughout our entire career. And we were particularly honored when he wrote the foreword to our book. And we couldn't agree with him more when he wrote that statistical process control has been called one of the greatest technological innovations of the 20th century. And Walter Schuhart introduced the control chart in the early 1920s. So it's hard to believe that we're actually coming up on the 100-year anniversary of the control chart. And there are many things that contribute to the staying power of this simple technique. You know, for example, you know, it's definitely grounded in things that are very important to us, even today. So the idea of studying the variation of a process and trying to divide it into two components as common cause variability or special cause variability is something that we continue to do every day in our jobs. And providing a control chart which, flags at a 3 sigma limit to say something might have special cause variation is very, very easy to use. And, I remember I had a teacher that would say that he loved SBC because it was a tool for the masses, right? And so it's pretty straightforward mathematically. Most control chart techniques are based on simple calculations of the mean plus or minus 3 sigma. And I know throughout my career, I have seen SBC actually implemented out in the production floor with operators, where they have, large sheets of paper where they're taking data, doing hand calculations, and plotting the point on a control chart. For me, this is kind of the true definition of real-time SBC. So very, very simple to use. And finally, it's very applicable. So I wonder if, Walter Schuhard realized how broadly this technique was going to be used. And, something we've used in every industry we've worked in, which has been, semiconductor, chemical, biotech. It's used in many industries. It's also used in a lot of applications. So besides for the traditional applications in manufacturing, I've used it in finance and service industries and, things around customer feedback. And not only is it applicable, but I think those core control charts have been around for 100 years. I have been using X bar R charts, X bar S charts, P charts, U charts in all these different industries. And my favorite really, the individual moving range chart, which has broad flexibility. So in an academic setting for folks who are taking the classes, these tools and techniques are still used in industry, and folks will be expected to be able to deploy those when they get into the workforce. But the biggest reason for the staying power of the control chart and SQC techniques in general is because they work. They have contributed to many improved quality and reliability and reduction of variation. And in today's environment, nobody has the patience or the time to do things that aren't contributing to the business. So as I mentioned, these are tools and techniques that are widely used, and folks will be expected to use them when they start working in these different areas. So besides for being great practitioners of all the tools under the SQC umbrella for many, many years here, Jose and I have also done a lot of teaching of these tools and techniques to engineers, scientists, statisticians. And so every year we get a new batch of college grads, that enter the work environment. And, they need to learn these techniques because they're going to use them in the job, and we have given many classes. So we have a list here of what we think is important to include as you're trying to teach students these techniques so that knowledge transfer is effective and people can hit the ground running in using these in their jobs. So the first thing is a good instructor. These are very hands-on, practical tools that are used in many settings. So, trying to emphasize, a little theory is okay, but really trying to emphasize the purpose of the tool, how to carry out the calculations, and most importantly, how to interpret the results to actually get those benefits that we described. That's really important in an instructor as he's teaching students in these techniques. Another important aspect is just having a sound and practical book. So, we need something that is a good balance between the theory and the statistical underpinnings, but also, as I've already mentioned, that illustrates the usage and how we use the output. And Professor Montgomery's book is really, key here. It's a great book. All his books are really good. And in our opinion, they're so good because he is an engineer. He has engineering degrees. And you can see that he brings that forth in his books and in his teaching by really coupling the statistics with the practical applications. And when you're a student, that makes a big difference. Next important area is having relevant examples. I know I went through my many degrees, and every single class I've had, you're always asking yourself, how am I going to use this in industry? And why am I even learning this? How, what relevance does it have? And, luckily for you professors that are on the line, SQC techniques are used so broadly, many areas 100 years later. This is a pretty easy task to implement and discuss relevant examples, and that's where our book comes in. So not only do we walk through all of the examples that Professor Montgomery describes in the text, but we also add a section called Statistical Insights, where we kind of throw in our 2 cents of how to adapt these techniques to real life settings and industry that we've encountered over our careers. And finally, easy to use software that's up to date and reliable is really important. So we talked about the simplicity of some hand calculations, but in today's environment, we have so much data, and it's really not practical to do things in Excel or by hand. You really need a powerful software package, and that's where JMP comes in. And we've been JMP users for years, and it has a fantastic set of tools in many areas, and in particular under the SQC umbrella. I think we talk about 20 plus platforms in our book that can be used for SBC, measurement system analysis, understanding product quality. And when we were going through Professor Montgomery's book, there's tons of examples there. And to really, kind of get the full benefit, the learning experiences of the student, there's just no way you can do hand calculations for everything. There's a lot of complexity there. And I think the most relevant thing in using these tools in industry is the ability to visualize. And so JMP has some fabulous platforms that really help you look at your data, visualize it, and really understand it better so you can make, better impact in these different environments.
Thank you, Brenda. So the other piece that Brenda was mentioning is the relevant examples. And as she mentioned, we give step-by-step instructions on how to use these techniques with a lot of screenshots and outputs from JMP, so you can see how this is done. And as she mentioned, we also have a section in every chapter of our book where we provide statistical insights about our experiences in the different industries that we have worked on, and also some of the innovations like process stability metrics and the process self-assessment that have been incorporated in JMP. So now it's easy to perform these calculations, and as Brenda said, visualize things, because that's one of the key things in JMP. So our book, this is the content of our book. We have follow the chapters in Professor Montgomery's Introduction to Statistical Quality Control. So you can see we had control charts for variables, attributes. We had a process measurement system capability. JMP has also something that I think he's the only software that has these, that on top of the traditional gauge and R, it also provides a way of doing a measurement system analysis. That's EMP, which stands for evaluating the measurement process. We also go through the cumulative and exponentially weighted moving charts, some advanced statistical process monitoring techniques, and multivariate techniques. But there is a chapter that we added to our book, which is this chapter 6 on process self-assessment, that is not available in at least the 7th edition of Professor Montgomery's SQC. And again, this has to do with some of the new techniques and metrics that has been developed. So I'm going to demo some of these things. I'm going to look at control chart for variables and control chart for attributes. I'm going to show you how easy it is to generate X bar and range charts. And I'm also going to show you how to do some P, MP, and C charts. And we're going to show you the process self-assessment, what that is, the stability metrics, and the process screening platform that is new in JMP 13. So we're going to start with an example from Professor Montgomery's. This is in our book, it's chapter 3, control charts for variables, and it's example 6.1, and that's the flow width data from a semiconductor process. And in terms of statistical insights, we're going to talk about a phase chart and an OC curve. And yes, not only you can do OSI curves or sampling plans, but if you didn't know about this, you can also generate an operating characteristic curve from a control chart, and that's easy to do in JMP. So this is JMP. This is JMP 14, which is the latest version of JMP. This is JMP Pro, but all the things that we're going to show can be done with a regular JMP. So you don't need JMP Pro for some of these techniques. So let's look at chapter 3, example 6.1, and these are flow width measurements of the resist that is put on semiconductor wafers when you're manufacturing integrated circuits. There are 25 subgroups of 4 wafers each, and there's an hour between the subgroups. So every hour, people go select some wafers and measure the flow width in each of them. And let me show you the data. That's the data. So you have a sample number, you have a wafer number, and you have the width in microns. And again, I misspoke, is 5 wafers per hour. So the sample number there corresponds to an hour. Okay? So the first thing you normally do when you are establishing an SPC program is to develop the control chart. So in this case, since we have subgroups of size 5, we're going to be using an X bar and R chart. So we're going to calculate the limits, and then we're going to save the limits for future use. So if we go to JMP, there's the Analyze menu, and within that menu, towards the end, you can see the Quality and Process Platform. Okay? And these are all the things within that that are related to SQC. So you can see the first one is a control chart builder. You have the measurement system analysis. You have variability charts, process capability control charts, a new platform that came out in JMP 14, which is the QSUM control chart platform, and some of the more traditional tools like a Pareto plot and a fishbone diagram. But I'm going to start by showing you the control chart builder. If you are a JMP user, you are probably familiar with the Graph Builder, which is one of my favorite tools in JMP. The Graph Builder is a tool that allows you to generate different types of graphs or visualization of your data by simply dragging and dropping columns into the different areas of the plot. So what the people in the SQC side of things in JMP did, they took that platform, the Graph Builder, and they developed what we call the control chart builder that works in the same way. So here, when you open the control chart builder, you'll see your variables here, and we're going to grab our measurements, the flow width, and as easy as just dragging and dropping. If you do that by default, then JMP is going to give you an individuals and moving range chart. That's what you see with the limits here. But in this case, we know that we have a subgroup variable, which is the sample number. And within the sample number, there are 5 wafers. You just grab that, drop it on the x-axis, and notice now how the sample size is 5 because it figures out that each subgroup is size 5. And now automatically it changed from an individual chart to an average and range. So now you see the summaries, you see the lower control limit, the average, and the upper control limit for the average chart, which is this one, and then you have the lower, the average, and the upper control limit for the range chart. That's it, as simple as that. Now, so you can generate a control chart. The other thing that we're going to do here is just save the limits. So if you go to the red menu here right next to Control Chart Builder, you click on it. Notice there's a menu there where you can save the limits. So you can save the limits into the column that has the data. And for those of you who are not familiar with JMP, one thing that happens with every column in your data table, you can store metadata. And some of that metadata are, for example, specification limits, control limits, the units of your measurements, and different things. And that is very helpful because if you do that, then that information is preserved and is part of your data table. So when you generate control charts, for example, JMP is going to go and grab that metadata. Another thing you can do is to save these in a table, and that's what I'm going to do so you can see it. And you can see here that you save in the standard deviation, the mean, the control limits for the X bar chart, and then the same for the range chart. Once you're done in this platform, you just click done, and that's your chart. You can save this chart to JMP. If you're not familiar with JMP, JMP has something called save script, and you can save that to the data table. And what that does is saves your program, so you don't have to go through the menus again. And that's what I've done here. So you notice there's one called Export Chart Builder. If I click there, it generates the same chart that I did. So once you design your chart, you can save the script and use it for the future. So the next thing that we need to do, okay, now that we have those limits, is, for example, if we get into phase 2 control chart. Let's say now we have some new data. Okay? So this is table 6.1 and 6.2. So Professor Montgomery in his book, he also gives the table 6.2, which has additional data for this process. And this is a table, and we have created a column to identify the original data and also to identify the new data. So you notice the first 125 observations, those are the 25 subgroups of size 5. Those are this, and then that's the additional data. Okay? So if we want to apply the limits that we had, okay, how do we do that? Well, again, we can go to Analyze, Control and Process, Quality and Process, Control Chart Builder, okay? And as we did before, we can grab our measurements here, the sample number, and that's our chart. But if we do that, then JMP is just going to calculate limits using all that data. But what we want to do is to use the limits that we calculated before. So you can go to the red triangle, and that's a place, you know, in every JMP platform, you're always going to see these red triangles. And I want to tell people, just click, because there's a lot of things you can do apart from the ones that you see in the main menus. For example, here I can get the limits, okay? And it will point me to your file structure here, and I can, you know, find where that data is. This is right here, and is, you know, table 6.1 limits. And that's why I save the limits to a table. You know, you can do it both ways, as I mentioned, but this also is helpful if you need to keep track. Then now you can see that the limits now are the ones from the table that we saved, and there is a note there that says, note that the limits were imported from a limits file. That lets you know that, you know, JMP is using those limits and not the ones calculated from the data. So right away, you can see that there are 2 points here that are out of control. Now, if you look at here, there's extra menus here to control the appearance and the calculations in the chart. So right now, the points 1, that means the first chart, the statistic that's being used is the average, and the limits on these are calculated using the range, as is determined by the X bar in our charts. And then the range chart, the statistics is the range, and the limits are calculated using the range. But you have warnings, and the warnings, that's where the tests are. So for example, if I want to test if the limits are outside the plus or minus 3 sigma limits, I can simply click here, test 1, and you can see that those 2 points are out of control. And this is the same as figure 6.4 in chapter 6 of Montgomery's book. Again, if you click done, then that's your chart. So this is a chart in phase 2. We got collected new data, and we're applying the limits that we calculated using the first 25 groups to the new data. Again, this is very, very easy to do. Let me show you some of these nuggets here, gold nuggets in JMP to do extra things. These are out of our statistical insights section. Let's again go to the control chart builder. Okay. And again, we grab the data, put in the Y. If you don't specify the subgroup, as I said before, you get an individual chart. But the moment you add a subgroup, notice how this is going to change. Okay. So now the subgroups of size 5. Now, Notice at the top there is an area called phase. This is what allows you to use a categorical variable to partition your data into the levels of that categorical variable. So for example, let's say I want to compare the original data with the new data. Rather than doing two separate charts, I can do that. I can go to the control chart limit builder and do a chart with the original data, and I can do the same with the additional data and then put them side by side. But if you have that column that identifies the original and the additional data, which is a source column in our data set, then you can just very simply just grab that and drop it on top and look what happens. Now we have limits here, both for the original and the additional data. So you notice right away that the new data is higher on average. Those are the green lines. So this is a visual comparison. The average of the original data was 1.32 microns. The average of the new data is 1.39 microns. So right away you can see that. And you can also do a comparison of the limits. Okay? So very simply, you can do calculations of limits for different categories if you have a categorical variable. Another thing I want to show you within the quality and process is another menu, which is the control chart. This is the legacy menu because most of the charts can be done now using the control chart builder. But I'm going to show you you can also create a chart here, okay, just by selecting control chart and XBAR. So let me do that with the original chart. Again, analyze, quality and process, control chart, XBAR. Okay. Sample number is the sample label, and the process variable is just a process. That's all you need to do. JMP will figure out the subgroup size from the sample number. But if you, for example, know that your subgroup size is constant, you can specify that here, or you can specify the statistics for your chart. Now you click OK, and then you get this chart. This is slightly different from the ones from the control builder. You don't have the summaries, but you have the limits. So this is more of a traditional chart. Now, if you click on the area, on the graph area, the first menu item is chart options. Okay? And if you go all the way to the bottom here, you have the OC curve. And the OC curve is the operating characteristic curve. If you are familiar with sampling plans, that's something that is used there to evaluate how good a sampling plan is. Same thing can be done here, but this is for a control chart. So what this is doing is plotting beta, or the type 2 error, the probability of not detecting a shift in your data as a function of your process mean. So if you're up here at the mean, okay, so at the mean there's no shift, there's a probability of not detecting a change is 1. But as you move away from the center of the chart, then you notice that that probability decreases, meaning it's easier to detect a change in the mean. Again, the short charts are designed to detect large changes in the mean. Now, this is done from the data, but you can also do something by, if you want to standardize this to a traditional plus or minus 3 sigma. So you can, for example, put a target of 0 here, put a sigma of 1, okay? And then we have to change the lower and upper control limits. If we were dealing with individual values, then these limits will be plus or minus 3. But here we also have to take into account the sample size, so that the limits here for the OC curve, if you have subgroups of sizes different than 1, is going to be plus or minus 3 divided by the square root of the sample size. So it will be, for the lower limit, it will be minus 3 divided by the square root of 5, and that happens to be 1.34, and the upper limit then will be 1.34. The last thing we have to do is modify the limits, the axis, the x-axis. And if you right-click here, you get a menu, and you can change the axis settings. So here we're going to go from minus 3.5 to 3.5, and we're going to do that in increments of 0.5. Right? So now you have your operating characteristic curve for a standard control chart with plus or minus 3 sigma limits for sample sizes of 5. Okay? And again, if you, for example, this is a crosshair tool, which is very, very helpful for this type of things. You can put it there. So you can see that right there. At 0, the probability is 1, but then as you start moving away, then you can see how that probability changes. Okay. So for example, if you are at, let's go here, at about 2 sigma, okay. So the probability of not detecting a change, if your change is of 2 sigma, is about 0.071. Okay. And this calculation is in chapter 6 of Montgomery's, and that he gives a value of 0.0708. So again, these, if you're teaching these, you're teaching the operating characteristic curve for a control chart using Professor Montgomery's book, then you can show the student how easy it is to get these numbers. Okay. Clean house here a little bit. And now we are going to do some control charts for attributes, and then we're going to go to the chapter 4 in our book. This is chapter 7 in Professor Montgomery's book, and we're going to be using example 7.1 and table 7.1. That's the orange juice cans. And then we're going to talk about over dispersion. Okay. This is a good place for questions in case we have some.
We do have one question, which was just about where the limits are coming from. So when you see the upper control limit and the lower control limit, was that plus and minus 3 standard deviations? Is the standard deviation from the groups? And then when you did a separate data table to bring in your own limits, where would those limits come from? How would you develop that table?
Okay. So the limits come from the calculation, traditional calculation of limits, as they're mentioned, plus or minus 3 standard deviation, but the standard deviation estimate is coming from the subgroups. It's not the overall standard deviation. Is coming from the average range divided by the constant D2, and that's what you do here when you run the control chart. So these limits are that. The average, which is 1.5, plus or minus 3 standard deviations. That standard deviation, we call that the short term or the within variation. Now, what you mentioned about the limits, you can go here and you can save the limits. And that's what I did. You can save that in a new table, and that's what it is. So if you notice this table and these limits, they're all there. And now the first entry is the standard deviation. That's the standard deviation that is used to compute those limits. And that's the one that's come from the R bar over D2. And the D2 here is the one for subgroup size of 5. Now you can save this. If you go to the file menu, you can save this as a given data table anywhere in your network, and then you can call it back. Okay. So again, this is a way of preserving the calculations. As I mentioned, if you go into phase 2, then you can use these limits with the new data, which is what we did with the additional data. Hopefully that answers the question.
I think it does. That was great. Thank you so much. And that was our only question in this part. If anyone else has a question and you want to slip it in quickly, write it in the chat. I don't see anything else coming in.
Okay.
Okay. Thank you.
So we're going to use example 7.1 in Professor Montgomery's book, and that has to do with the frozen orange juice concentrate cans. And the way the process works, you get some cardboard, you spin that, make the can, and then put a lid at the bottom, a metal plate, so to speak. And you inspect those cans for the possibility of leaking, so you classify them as good or bad, so to speak, or conforming and non-conforming. So you're counting for the ones that you made, how many are non-conforming, which means how many have the possibility of leaking when we add the frozen concentrate there. So this is a classic example of a P or NP chart because it's binomial data. So you either have conforming or non-conforming. So it's a discrete type data. So this is where the P charts come in. So we're going to, again, use the control chart builder to do some P charts and P charts. And then I also will show you how to do that with the control chart. So this is the data. This is from table 7.1 in Professor Montgomery's book. And you have a sample number. You have the number of non-conforming cans. So when the first batch of cans that were made, there were 12 out of those that were non-conforming. And here the sample size is 50. You have it here. So in this sample, there were 50 cans that were inspected. 12 of them had the possibility of leaking. And this is just the average of 12 divided by 50. That's the sample non-conforming. So we're going to use the control chart builder again. And this is what I was saying. I show you the other control chart builder menu where you have the control charts by type. Here, this has some built intelligence, so to speak, that figures out what type of chart you're using. So let's grab the non-conforming cans. We're going to put it here. Okay. And notice right away that JMP figures out that you're dealing with counts. So that's a statistic. Before the statistic was the average. And now the limits are computed using a Poisson chart. But in this case, as I mentioned, you have pass-fail data, conforming, non-conforming. So we're going to go to a binomial. Okay? And notice right away they tells you, well, I cannot compute the limits because I don't know what the sample size is. Okay? And that's very easy to do. You see this entry here in warnings called end trials. That's where we type 50 because we know that each time we inspected that, we inspected 50 cans. And that's all. Notice that. Then JMP figures out, okay, you have 50. Now I can do my calculation. So these limits, again, are plus or minus 3 sigma limits, but these 3 sigma limits are based now on the binomial distribution. Okay? But here we're doing an NP chart. What I want to see is a P chart. So that's very easy to do. You can change the statistics from count to proportion. So now you have the fraction defective chart. And this is the same as figure 7.1 in Professor Montgomery's book. So you notice it's very easy to do a P chart. Okay? And by the same token, you can do the NP chart just by changing this from a proportion to a count. So now your limits are 2.6 to 20.5, which are also limits given later on in that chapter where Professor Montgomery shows the NP chart. Okay? So very, very easy to do. And again, if you want, you can, as I showed you before, you can save the limits here in a new table. And you notice these are the limits from the chart. Okay? The other thing is the other menu. I show you the quality control chart menu. And here you can select P or NP charts. It works slightly different, but again, we can put the non-conforming, the sample label, and then the sample size. Again, we know that is 50. And you get the chart. Okay? Same chart as before. So very easy to generate. So you'll notice that with a control chart builder, you can generate P and NP charts very easily. So that's all contained there. So let's look at what happens with another set of data. This is from the help library in JMP. They have a wafer data set. And what we did is we grabbed those wafers and we counted the number of defects per lot and wafer. So now this is a count because it's the number of defects. It's not pass-fail. So this is an application of C charts, which is a Poisson distribution. Okay, so let's do that. Let's open the data set. So notice you have a lot here, lot number. You have 25 wafers per lot, and then you have a wafer number. So we're going to look at the defects per wafer. So if you're familiar with semiconductors, integrated circuits are made in wafers. Wafers have different diameters, and you can put a whole bunch of integrated circuits in the same wafer. So out of this one, we found that there were 16, 14, 19, 69. So let's do that again. So now you know how to do it. You go to the control chart builder very easily. Now we're going to select the total defects, and we're going to put the wafer number. That's our X variable here. And we're just going to check here. And the statistic is not a continuous chart. It's an attributes chart. So notice that you have a menu here where you can change that. So we're going to change that to a sugar chart for attributes. Okay. And now what we're dealing with are counts, and we're using a Poisson distribution for a C or U chart. Perfect. Okay. Now let's test this process. I'm going to go and select test, and I'm going to do test 1. What happens? It's a lot of red in here. Okay. So this process is completely out of control. Is that true? So one thing that happens with count data in industry is that there is this phenomenon called over dispersion. So let's look at the distribution of this data. Let's go back to our table. Let's go to analyze. Let's go to distribution and get the total defects. Okay. And get a histogram. Right? And that's our data. Okay. If we use a C chart, underneath we're assuming that the data is distributed or can be approximated by a Poisson distribution. Okay. But in a Poisson distribution, the mean is the same as a standard deviation. Yeah. So here you notice that your mean is 142, but your standard deviation is 360. Okay. So you notice that your standard deviation is way larger than it should be. Okay? Way larger than it should be. And that's a phenomenon called over dispersion, which means that the variation that you have in your data is larger than what you expect using a Poisson distribution. It's another way of checking that. One of the things that is nice about JMP is you can fit different distributions. So let's fit a Poisson distribution. Okay. We fit a Poisson distribution. We get the estimate of lambda, which is 142. Okay. And then you get the likelihood, and then you get some information criteria. The information criteria are helpful because you can compare different distributions using the information criteria. So one thing that we do in industry when we have this type of data is not to use the Poisson distribution, but it's to use a negative binomial distribution, which is equivalent to a gamma Poisson distribution. So what happens is you have the Poisson distribution, but you assume that your lambda parameter on top of that is distributed as a gamma. So again, we can go here, discrete fit, gamma Poisson, and you get this other thing. Now you can see that under the Poisson distribution, the Akaike, the corrected Akaike information criteria is about 53,000. But when you use the gamma Poisson, that goes down to 1,400. So it's a great reduction. So in information, using the information criteria, the smaller is better. So this is telling us that the gamma Poisson is a better approximation for this data. Okay. Which means that rather than using this control chart, we should be using a control chart using the negative binomial distribution. Okay, how do we do that? Because whenever we do control charts, we go back to the control panel, we either have the Poisson or the binomial. How do we get a negative binomial chart? Okay. Yeah, we can probably do it by hand, or you can write a JMP script to do that, but that's built in JMP. So there is something called rare event. And if you do that, then you notice that you can do a control chart either using the negative binomial or the Weibull. So this is our negative binomial chart. We can do the test now. And you notice that our process has only 2 points out of control. Okay. So the control chart that we saw before, the C chart, had a lot of points out of control because we were not using an appropriate distribution. So again, these are some of the insights that we share with you in the book, and we show you how to do that in JMP. So it's important to figure out what the mechanism that is generating the data is, so we can use the appropriate distribution. Any questions?
I don't see any questions yet. Does anyone want to post anything in the chat or the Q&A? I'd be happy to pass those questions on. Nope, we don't have anything. Yes, we do. How many distributions are available?
Within the distribution platform or within the control chart?
I believe within the control chart.
Yeah, so in the control chart, you have the traditional ones, the Poisson, the binomial, and the normal distribution for your variables. And then within the rare events, you have either a negative binomial or a Weibull.
Okay, great.
So this is not there yet, but the case of over-dispersion also happens with binomial data, and then the distribution that is used there is the beta binomial distribution. That is not available yet in the control chart platform.
Okay, fantastic. Thank you. I don't see any other questions right now.
Okay, the last thing we want to show you is the process health assessment. So how do you assess the health of your process? So this is where the stability metrics come in. Most of you are familiar with the CPK or PPK, which is a metric to determine if your process is capable or not. But for control charts, we don't have that. Or let's say, correct myself here, we didn't have that. So Brenda and Professor George Runger from ASU back in 2006 developed a metric, a stability metric. So something that you can calculate and attach to a control chart. And that SR, the stability ratio, is the ratio of the long-term variation, which is the variation computed using all the data, divided by the short-term variation, which is the variation that comes from the control chart. If your process is stable, this ratio is close to 1. Okay? How close to 1? Well, you can approximate the SR ratio by an F distribution. You can actually do a test to see if your process is stable. So the SR provides a stability metric that you can associate with your process. So now you have a stability metric and you have a capability metric. So another thing that was introduced in the process screening platform is something I developed back in 2005 that I call the process performance dashboard. In JMP is called the process performance graph, and is a way of combining the stability ratio on the x-axis and the capability ratio on the y-axis. So if you do that, then you have 4 combinations, 4 quadrants. And this is inspired by Dr. William Chambers from their book Statistical Process Control, and where they talk about the 4 possibilities of a process. Your process can be stable and capable, stable and not capable, unstable and capable, and not stable and capable. And those are the 4 areas here. So once you analyze your process, you can calculate a PPK, you can calculate the SR ratio, and then you plot it here, and you can see where your process is. So this is a way of assessing the health of your process. And here you can analyze multiple processes. Let me show you an example. This is some process health data. These are individual measurements taken over 7 different processes, A through G. Within each of these, there's the metadata. So every column here has the spec limit, so the PPK calculations can be done. So here we go to analyze, not to the quality and process platform. The developers decided to put the process screening within the screening menu. So there's kind of some logic there because you're screening your process. But on the other hand, this is a tool that belongs in the quality or SQC arsenal. And this is what Brandon mentioned at the beginning, that in the book we cover about 20 different platforms to do statistical quality control. And this is one of them. So you select process screening. And what you have to do is just select the processes. We're going to select processes A through G. and the subgroup variable is optional. Uh, Here will be the sample ID. And by default, it's using an individuals and moving range chart. So you can use an X bar and R, X bar and X, and different combinations of that. So you need to know how the data was collected. In our case, our data uh, are single measurements. And that's it. Once you do that, then you get a table where it shows you the stability ratio. Okay? And this is the ratio of your overall sigma by your within sigma, long term and short term. And it gives you a lot of information about the control charts, the alarm rate, how many things were out of spec, and your CPK and PPK. Now, with that information, now that we have the PPK and the stability ratio, then we can generate the plot I was telling you about. And that's a process performance graph. So you can see right away that there are three processes that are in the green zone. That's what we call the ideal state. They're capable and stable. And there are all these three. So you can select them and you can see where they are in the table. And this is one of the things in JMP that everything is linked. The graphs are linked to the reports. They're linked to the table. Another thing that you can do here, once you have selected this, which is very helpful, if you go to the red menu, you can generate a control chart for the selected items. And here we are. So that's the control chart for B, for E, and F. So you have all the information about the control chart plus a capability analysis all in one. So, and these are where the process summaries are, the short-term sigma, the long-term sigma, and Brenda's stability ratio. For parameter B, that was 0.96. And these limits here, by default in JMP, the limit is defined as 1.5. The capability here is defined as 1.3, but there's another way of doing this and defining these not by a given value, but also by a p-value. As I mentioned, the stability ratio can be approximated by an F distribution, so you can test to see if this is close to 1 or not. So this is very helpful. There are other things that you can do here. You can do a gold plot, and this is a plot that shows you the different capability indices. So these are the ones that are very high, and then these are the ones that are between 1.3 and 233, and these are the ones that will be in the green area greater than 1.33, which is the default value, but you can see here that you can change it to any other value. So if your company is Six Sigma, for example, you may change that to 1.5 or even 2. Okay, and if you do that, you can change it manually, or you can put the value here. So if we put 1.5, everything gets updated. Okay, so that's it. What we have for the process screening platform. It's a very helpful way of analyzing multiple processes, as Brenda mentioned. You have tons of data these days, multiple processes that are running. So this is a way of getting a quick snapshot of where you are in terms of capability and stability, and it will allow you to prioritize things. So these processes you have to worry about. This process here in the yellow area is capable but unstable. Even though you're within specs, because it's unstable, we really need to look into that process, because being unstable means that you don't know where it's going to be tomorrow. So tomorrow may be out of spec. Here, you're stable but incapable. At least you know that you're predictable, so you can figure out ways of controlling the out of spec. And this area, the red one, we call it double trouble because you're incapable and you're unstable. So another good place for questions before we wrap things up.
Okay, again, I don't see any questions in the chat or Q&A right now. If you have questions, please type them into the chat or the Q&A. We've got a few more minutes, so we'd be happy to take a few more questions. I don't see anything.
Okay, yep.
One person actually just asked where they can get a copy of your book. Great question.
It is. Yeah, so yeah. That information will be provided. You can get that through SAS Press. I think it's also available in Amazon. but we'll be
Yeah,
providing.
I'll put up a slide at the very end to show everyone where they can find the data sets for the book, where they can request the book. If you are teaching with JMP and you want to be considering this book for use in your class, SAS Press will send you a free copy if you fill out a form showing that you're a professor. So I'll point out some of these in just a moment. Any
Exactly.
other questions?
And as you mentioned, Ruth, there is a website within JMP that has all the JMP data sets for our books. Again, if you're teaching, that's very helpful. And all those JMP tables have the scripts where you can run all the analysis and go along. So.
Yeah, and just to clarify, the examples that we reproduce are in the main verbiage of the book, not the examples, the exercises for the students in the back.
So yeah, so if you're teaching, you're okay. We're not giving away the exercises.
Okay, wonderful. All I'm getting at this point is thanks for the talk. Great talk, marvelously instructive and helpful. So we appreciate your feedback. Thanks for that. And thanks, Jose and Brenda.
Yeah, so we want to close with, again, this is a quote from Professor Montgomery's foreword. We're so lucky that he wrote the foreword to our book, and this is what he had to say. And finally, we want to thank Professor Montgomery, because we know him for a long time. We learned from him. We collaborated with him. And for us, it's an honor to be able to write a book for the standard, the Statistical Quality Control. People at SAS Press, especially Catherine, she was the editor for her book. And it's marvelous to have a person like her that helps you all the way through in writing a book. Sharon Roberts is the new director of the SAS Press. And then from JMP and the JMP academic program, Kurt and Ruth for helping us and putting all this together.
And we are so pleased to be able to have you guys as guest speakers today. So I'm going to grab back control and just put up a slide to show everyone where they can find a recording of this video and or a recording of our webinar, and also a link to the data sets and things like that. So here, if you have any questions, if you'd like to know more, or if you forget where we told you to go to after this webinar, just send us an email at academic@jmp.com, and we'd be happy to help you get access to this book or get a copy of JMP or whatever you need to be able to follow this advice from today. If you want to watch the video from this webinar, I will post it later today. You can get to that link from jmp.com/webinar. You'll be able to click on our recorded videos link, and then you'll find a copy of this, or the title of this webinar. So you'll see the link to the video there. You'll also see a copy of Jose and Brenda's PowerPoint slides, and a link that will send you to where you can download the data from the examples that they were using, which again will have those saved scripts. So you can just click on those little play buttons and repeat the whole analysis, or you can follow the instructions in their book and learn how to use JMP for those things. And again, if you want to get a copy of this book, I'll post information for this on that website by the jmp.com/webinar, but you can also just search the name of the book. So their book is called Doug Montgomery's Introduction to Statistical Quality Control, a JMP Companion. So search on that and you'll find a SAS Press page. Or if you'd like, you can copy down the link that I have below. That is the direct link to the page, but it might be easier to just Google search this. Okay, well, thank you all for joining us. We are ending right on time today. We really appreciate Brenda and Jose joining us as guest speakers. We're excited about your book, and we hope lots of people get a lot of use out of it. So thanks, everyone.